Welcome everyone. Today we're going to be talking about channels. Come from a language like Golang, you're going to be familiar with channels because that's all they have there to solve their concurrency and parallelism problems. In C# channels is a relatively new feature, and the primary problem that channels solve is a producer-consumer problem, right? So if you can find a mental model in your code that something is producing something and then another thing has to consume it, you've pretty much want to use a channel because that's a very good solution for it. And a lot of cloud providers also, they provide these channel solutions, pub sub queues, publisher subscriber queues, which is essentially a channel. So it's a quite frequently used technology, and how it works can be a benefit, right? So first of all, we're gonna start with a quick example of why you might want to use a channel. Then we're gonna jump into how it's made, essentially at more of a higher level view, because on a low level the channel is made using more lower level concepts to make it more efficient. But we'll just have an overview of it, and then we will go into Visual Studio, into an ASP.NET Core project, and we're gonna see some actual use cases for it. Okay, so let's go ahead and get started. So a simple example here is we want to send a notification, and this might entail something like a slight delay, right? We will have to communicate with some external service, and let's go ahead, get the awaiter and get result. Okay, so this is a blocking operation, and it's a blocking operation not in a sense that I'm blocking a thread. Yes, I can make this asynchronous, but it's a blocking operation in a sense of a user making a request to your service, right? So imagine if a user makes a request to your service, and part of the request has to send out a notification. If as part of a response to the user has to wait for the notification to get created, he's going to be waiting, right? It doesn't matter what thread completes it, he's going to be waiting. So this is what we're simulating here. So we want to just go ahead and send a notification, and I'm obviously not printing anything, so let's go ahead and just dump the I here. So if you're not familiar, I've been using LinkPad for my lessons recently. The link is in the description. It's a really awesome piece of kit. But yeah, as you can see, what happens is the sequential execution, right? Which is pretty much what should happen, right? You make a request to the server, you update the product in the database, and then as part of that, somebody gets notified, right? But because it needs to go off to some service to send a notification, that user still has to wait for the request. So what you could do is you could put the send notification in a fire and forget task, right? So you're just gonna say, right, send off notification, I don't care when that finishes, etc. So what you will be tempted to do, you're just gonna go ahead and put run here, right? And voila, everything's sort of completed real quickly. And then let's say, just so we can get a visual on these tasks getting completed, right here we can see them just being blasted out, right? So what did we simulate here? We essentially simulated 10 people make a request, or you make a request 10 times, and all of these requests complete instantly, but then after some time the notification gets sent. Okay, so the problem with this fire and forget approach is the scope. Okay, so let's say this is going to be in a service, and usually the way you resolve services is you do dependency injection, right? So you dependency inject into a service, and then in this service, the send notification function is going to consume one of the services that was injected. Because we exit this scope before the notification is actually finished sending, the dependency injection is going to dispose of that service that was injected. Once that service is disposed, when the send notification is going to try to consume it, that's when the trouble is going to arise. Okay, and it's just going to crash, like the service no longer exists, right? So this is where you might want to use a channel, where you basically say, put a message of what you want to send in a channel, and then when a service is ready, it can pick it up. And also another problem with this solution, let's say you are running on a one processor machine, right? And you have, let's say 20 or 100 users one day, right? And they all generated 10 notifications each, okay? And let's say it says, because it's maybe a slow processor, it might take 1 second to send a notification. You're essentially flooding the task queue with these fire and forget tasks, and at some point your server is going to be slow to respond anyway, right? So you might want to limit the amount of tasks that get processed at the same time, and a channel can help with that as well, right? Because it does implement a queue. So before going into the Visual Studio examples, what I want to do is I want to go ahead and implement a channel ourselves, right? One real world problem I solved when I implemented a channel myself before channels actually existed in C# is the video processing problem. So video processing was a long running task, and kind of like YouTube, where you upload a video and then you can just even close the browser and your video is still processing into different qualities. That's essentially what they do. They take your task, they put it on a queue or a channel, and then something reads off a queue and starts processing your video. Okay, and I essentially did the same thing. And yeah, I'm just going to show you how I accomplished that. So this is going to include knowledge of the semaphore. So if you haven't watched that video, watch my previous video. If you know what a semaphore is, you're good to go. So a channel comprises of two real things. Is you want to be able to read from a channel, and you want to be able to write to a channel. Okay, so let's go ahead and make two interfaces. Okay, so public, where we want to read, and I gotta say interface. All right, and public interface, I write. Okay, so what are we gonna write? We are going to write some kind of type, right? And we want to be able to also read that type. Okay, so let's go ahead and push something into the channel. Okay, and it's generally a message, right? It doesn't matter what it is. It's some kind of message. And the whole thing about channels is that this message, kind of how we have a service in the scope of this main function that would be consumed by the send notification, instead of depending on the memory in the service of having another service injected into there, right? So it's kind of some kind of state of that service that needs to be for this function to be able to consume that service that was injected, right? So it's a state, it's memory of that service. Here, we don't depend on the state. We rather say, this is what's needed to produce the notification, this message, and we push it into the channel, and then something else reads off it, and produces the notification. Okay, so instead of depending on the state and sharing memory via that state, what we do is we share memory by passing it into a queue, and that's the whole philosophy behind the channel. We share memory by passing it around via channels instead of having global state, essentially. So here's something that we want to push. So we want to essentially be able to read this as well. Okay, and my queue is going to be a little bit limited. I'm also going to make this a task because this is going to be an asynchronous operation. We're not always going to be able to read from a channel. If it's going to be empty, we don't want to block the thread. Okay, so let's go ahead and import task. Pushing is a synchronous operation. We just push and we are. It's kind of like adding an item to a list. All right. Next thing we want to do is the writer can be finished at some point. It's not really necessary for ASP.NET Core scenario where your server is long running, but for this example, since I'm in Linkpad and my service shouldn't be running for a long time, I'm just gonna go ahead and implement a couple of functions that do actually exist on the channel, but you might not need them. Next thing will be void complete. All right, or yeah, let's say complete. So this is where we basically say, right, we finished writing to the channel, and here we can go ahead and say full is complete. Okay, and we can check, is it completed or not? All right, so here we will say push something onto the queue. Once we're finished, let's go ahead and say complete. Here we're gonna say wait to read from a queue, and when we're complete, exit. Okay, so let's go ahead and implement our channel. When I wake up today, go ahead and make class channel. We're going to implement a channel of type T, right? So this is the message that we're passing around, the data that we're sharing between threads, right? Or tasks even. We have an I read, T, and I write, T. Okay, so let's go ahead and implement these interfaces. All right, so we got a couple of things. The is complete stuff, let's go ahead and just quickly sort this out. We're gonna have a private bool finished, right? And if it's complete, it's void. We will just go ahead and set finish to true, and then here we just want to return finished. Okay, so that's pretty simple. Let's go ahead and put that in the bottom so we're not troubled with that anymore. What we really want to solve is this push read, and it's still being asynchronous. So the channel sometimes acts like a queue, so this is what I'm gonna implement. It's essentially, a channel is essentially a queue, which regulates how much items you can have in a queue, or who can read from a queue, essentially, right? Or when you can read off a queue in an asynchronous manner. So only read when we have items on there, okay? So we're gonna have a constructor from which we're going to initialize a queue. And since we want concurrency, multiple threads can be writing to this channel. We want concurrent queue, if I spell it correctly. There's gonna be some generic type queue. There it is. And it's gonna be of type T, right? So again, this is the message that we're passing around. And this is something that we're gonna need to initialize. Concurrent queue T. There we go. All right, so we have our queue. Essentially, this is where we put our messages. It's just like adding stuff onto a list. As soon as we add it, right, we finish the request, and then something else can go ahead and continue here, okay? So when we push stuff, we take our queue, and we go ahead and call enqueue, and this is essentially we push stuff onto the queue. We're going to put the message in here, okay? Simple enough. This is a synchronous operation, very safe. What we now want to do is we want to read stuff, right? So the way you read stuff from a queue is you try to dequeue, right? So it will return a boolean, but it will also out var t of your result, okay? So if we have something, let's go ahead and grab our out var message, and this is going to be of type T, and this is something that we can return, okay? And I will let this error for now because this is going to be asynchronous in a second, because this is the whole point, is to try to make it asynchronous. Something is going to try to keep reading from this, okay? So there's going to be two tasks. There is going to be a producer and a consumer, okay? The producer is going to put stuff, and the consumer is going to read stuff, okay? So when the consumer is waiting to read, we don't want the consumer to block the thread. So this is why this has to be asynchronous, okay? And this is why you need to know about the semaphore. This is how we're going to solve this problem. This is where we essentially say only so many items are on the queue, and this is when you can read, okay? So it's essentially our gate, right? If once we push an item, we want to basically say, right, you're allowed to read, right? Come in and read, or our messages will essentially be coming in and out, all right? So let's go ahead and get a semaphore, and we will essentially see how this works, right? And we'll just say flag. Let's change these two underscores real quick. Nice. So flag is a new semaphore slim and 0, because when the channel is created, we have no items in the queue, okay? Every time we push a message onto the queue, we want to say, right, consumer, you can come and read this message, okay? And understand that multiple processes, there can be multiple processes or multiple consumers for this channel, and as well as multiple producers for this channel. That's the whole thing about channels, okay? So what we essentially do, we put stuff onto the queue, and then we say, right, the consumer, come collect this thing. Here what we want to do is we want to essentially block, right, from our flag, where we're gonna, right, let me make this async so I don't get an error. We want to go ahead and wait async, right? And this is what the semaphore does. So we're gonna, a thread is gonna come in here and is gonna leave, right, until there is something on the queue. Once there is something on the queue, it's gonna go ahead, resume this task. It's gonna go ahead, push the item from the what's it called? It's gonna push a message from the queue, and then we're gonna return null here just to be able to return something, or I guess some types of t can't be null, so we just return default. If this is an int, it's going to return 0, ints can't be null. Okay, so this is essentially it for the channel implementation, right? It's really simple here. The Microsoft's implementation is a little bit more lower level to make it more performant. Let's go ahead and try to use this queue. Okay, so we're going to spawn 2 tasks, right? We're going to create a producer and a consumer. Go ahead, producer. The producer is going to write to the channel, right? So we want an iWriter of t, and we're going to have t here. Let's have a writer. And actually, I'm not going to put a generic here. I'm just going to say that I want a string, since I'm going to be passing messages around. Okay, and what I'm going to do is I'm going to say for int, let's say for like 100 messages, let's have the writer. We're going to go ahead, push our message. I to string, probably there it is. So we're going to push it, and once we're done pushing, we're just going to go ahead on our writer, say that we are complete. And this is a task just so it can run in parallel with the consumer as well. So let's go ahead and put a slight delay here, right? So not a big one, but you will see that this is going to be a blocking operation, but it's still going to run in parallel, right? So we're going to delay for 100 milliseconds, and let's go ahead and get a waiter and get result. Okay, at the end we just want to say that this task has completed, return, right? So there is no real necessity for having this asynchronous, as I've explained in my async await videos, that we just might want to run this in parallel. Okay, so this is the producer. Let's go ahead and create a consumer, and the consumer is going to be consuming iReader, or again, we just want this as a string, right? And this is again a task, so we want not for, but while, and we want to continue reading until it is complete. So we'll get that is complete, and while it's not complete, let's go ahead and grab the message. So var message, and we're gonna grab the reader, and we're gonna read, right? And this is a task, so we actually want to do something with this. So let's make this asynchronous. Let's await here, and we're gonna go ahead and dump this message, right? So we're just gonna have a number, and just to distinct, I'm just to be able to distinguish between this number, I'm gonna mark these as messages. What we're then going to do is we are going to just return, or no, we don't need to return anything there, right? One thing with this is complete thing is we could write all the messages and be completed before we've read everything. So where we have that is completed, what we all want to also do here is say and check if the queue is empty, right? If we're finished and the queue is empty, we're actually complete, right? Not when we're done writing. So let's go ahead, grab our queue and say is empty, right? So when we're finished and it's empty, then it's time to go. So we got these 2 tasks. One is a producer, one is a consumer. Let's go ahead and create a channel. Right? It's going to be a channel of string, right? Okay, simple. Now we want to await all of our tasks, where we're gonna have the producer, and we're gonna pass the channel here, and then we're gonna have the consumer. We're gonna pass the channel here as well. Okay, so that's essentially it. Let's go ahead and run it and see what happens. Okay, so I'd say quite an unexpected behavior. I expected them to go one by one, essentially, but what has happened is we kicked off this task first, and it's sequential. So what we want to do is kick off consumer first, because it is actually going to free up the thread. Okay, so let's go ahead, put the consumer and the producer here. So we're gonna first start this task, and then we're gonna kick off the producer as well. Okay, so there we are. You can see here that essentially we are pushing onto the queue, right, onto this channel, and then this consumer essentially reads off and processes these messages as they come. Nothing is stopping us from having multiples of these producers, right? So let's go ahead and change this up a little bit. We're gonna go ahead and wait on this delay, and we are going to make this asynchronous. So there's going to be one problem with this write.complete, which we're really not too bothered about in this example. However, in production, you want to use special techniques to combine writing channels or reading channels, right? So if two are writing to one or two are reading from one, you want to do something special to accommodate that. Okay, so let's go ahead and produce a few more tasks, right? So this is going to be 4 more channels, so around 40 messages, but you will see that there is pretty much a good amount of delay and the consumer is blasting through these items. Okay, so that's pretty much the channel in its glory. You can have a bunch of producers and consumers, right? So these these write to the channel and the consumer reads from a channel. And the primary goal is to not share this string in a global variable here, data, right? We don't want to share this data globally like these between the two tasks. We want to pass this data around between tasks. Okay, so that's the whole premise of this. So here in Visual Studio, I have a small setup, which I'm going to go over quickly. There are a few components, but it shouldn't be too much of a trouble if you've been using .NET Core for a bit. I want to demonstrate the purpose of why you want to use a channel and that concept of services being disposed after you've initiated fire forget, right? So what I'm adding is just an API with controllers, right? So map default controller routing with controllers. I have a notification service that I'm going to consume later. I have an in-memory database with Entity Framework Core, and I have an HTTP client that I can also inject. So closing that startup, where again we're going to come back to it, I have a simple home controller with a send action. Okay, so let me go ahead and fire this up. So I'm going to debug this. So with that running over there, I'm going to grab Postman and I'm going to just go ahead and press send. And you can see it takes around 6 milliseconds to complete 12, right? So it's pretty quick right now. So let's say some requests are going to take longer than the other ones, right? So we're going to have something along the lines of task delay. We're going to have 100 milliseconds there and here. So let's go ahead and wait here. And let's go ahead put another 200 here. Let's say we're doing some calls, right? Where these two calls are essentially us trying to dispatch on a notification, right? And what that might involve, we will see in the service in just a second. But let's go ahead and run that and let's see how we're going to make that offset. We're going to do a bump in time that takes for this request, and then we're going to again disperse it, and we're going to see what the problem is with this dispersion. All right, so let's go ahead and run this. You can see it's bumped up to 400 milliseconds, and it's going to go down after the first request, right? Because maybe some cache or something or whatever. But yeah, we're generally taking the 300 milliseconds that we have added here. So let's go ahead and offset them. If we have 10,000 users, this time is going to stack up quickly. Right, so we just want to go ahead and run this in a different function. Alright, it's going to be a fire and forget task. Something along the lines of this is going to happen, so let's go ahead and run this. And here, if we send, we can see we're going back to essentially 7 milliseconds, 6 milliseconds, 8. We are now offsetting, we're starting this different task, so it runs in parallel, so we're not waiting, we're basically saying, right, I do this thing there. So what is the problem with this? In favor of time, I've coded this up before the tutorial, just so we can quickly go over this and jump back into channels. I have a service here that I've registered that's called notifications. So it's in the services folder. I have here a data model, which is just a simple user. And I have a database, right, where I inherit from DB context, and I just have a users table. This is an in-memory database, and what this notification service does is it consumes this database, and it also has the HTTP client factory. So what I'm doing here is I'm doing a little C to the user, right? So if the user doesn't exist, this is just a safety precaution. I put a user if it doesn't there. So what I do is I might get some information about the users that I want to notify, their emails, their mobile device IDs, where am I going to be sending these notifications, what notifications do they have enabled, do they want to see these notifications, etc. I want to then go ahead and create a client. I want to be able to send that notification. I want to be able to store what I've sent. Have I sent this notification? Where have I sent it? And I want to save it to the database, right? So sending a notification is not as simple as just, oh yeah, send notification. Sending notification involves a wide variety of different notification settings. Which notifications are you allowed to see? What clients do you have enabled for notification? Is it a browser? Is it an app? Is it a is it an email, etc. Right? So it's an involved process. And let's say that this might take a second. It won't, but it might. Okay. So what I'm going to do is I'm going to go into my home controller. Let's go ahead and I'll leave this for an example. We're going to do a send a, and from services I'm going to inject the notifications service, right? Notifications. And what I'm going to do is I'm going to grab notifications and I'm going to say send them, right? And because this is a task of bool, I will just go ahead and say that this is a task of boolean. I'm just going to return this from the controller action. Yep, let's go ahead and run this. We'll just get a comparison of how long does this take. So now back in Postman, I want to go to send a now. I'm going to send it. And the first time it took around a second. Next time 88, 60, 80, 46, 44, 33, 37, right? So you can kind of get a sense of where it is. So let's say that this process, because we're using an in-memory database, it's quite fast. And if we're going to be using a SQL database that multiple services are going to be talking to, we're going to be in quite of a pickle, right? So let's go ahead. I'm going to copy this function. It is getting a little bit crowded here. I apologize, right? So let's go ahead and add a send a. Again, we're going to align this up. And what we're going to do is, yeah, let's first wrap it in a try catch so we can see the error clearly. We're going to catch exception. Import this e. And just so I can see it, let's go ahead and assign it here. And I'm going to put a breakpoint here. Okay. What I'm then going to do is I'm going to do the same thing. I'm just going to go ahead, put it in task.run in hopes to reduce the time that this service is taking. Okay. Like that. Okay, one thing that has happened here is that this lambda is not asynchronous, so we can make it async. And we don't really have to wait for this service. Don't have an asynchronous operation here anymore. So let's go ahead, change this to boolean. And it returns true there. Okay, so again, this is a synchronous operation. We create a task that should complete sometime later, and then we exit the function. We will then exit the action, and we'll exit the controller. And what's going to happen is we're no longer going to have access to these services, and when this task is going to execute, it's going to break. Okay, so again, let's go ahead and probably should have named it send b, but yeah, send b will be calling, let's say this is send b, we'll be calling send a on send a, right? Just a little miscommunication. Right, this is no longer a task. We're just going to be returning a boolean here. I'm going to be calling send a again, and we should be able to observe the error that I was talking about. Okay, so let's go to Postman. Let's go ahead, kick this off. And here we are at the exception, right? So what does error say? Let's go ahead. Can we? Where's my magnifying glass, buddy? There it is. Okay. So cannot access disposed object. A common cause of this error is disposing a context that was resolved from dependency injection and then later trying to do the same context instance elsewhere in your application. Yeah. So yeah, basically this does not retain the state of the service, and this is what I was talking about at the beginning when I was explaining with the little basically fire and forget task, is that these services that we resolved here, they're no longer available to this task because we actually finished exiting the scope. Okay, so this is the problem with this fire and forget solution, and as well as we're basically creating a stack of tasks that might over time take over our process and starve other threads. Okay, So let's close everything and let's think about how can we offset this, right? We essentially want to have this notification service as a producer for notifications, okay? And then we have a consumer as a dispatcher of notifications, okay? So we will have to have a process that is sort of trying to read off a channel. And this is some where you can use a hosted service or a background service, right? So this is where we're going to go into services and we are going to add a hosted service, okay? I understand at this point, maybe if you're wondering, where the heck are the channels? We haven't seen the implementation of the channels. It's more important to understand what problem the channels solve rather than the channel itself, because the channel is dead simple. It has a couple of functions that are really easy to figure out. You just need to know where to put the channel in the bigger picture, okay? So hang in there. So a hosted service. Let's go ahead and create a hosted service, and this is just going to run in the background of the ASP.NET Core application. It's not going to be able to be hit by a request. It's something that we can put the channel, can plug the channel into it and send stuff into it, and we'll process it in the background, right? So let's go ahead and create a notification dispatcher, right? So we have a notification dispatcher. We are going to make this AI, or rather background service, right? So background service inherits from iHosted service, and then our startup and add a hosted service accepts a T-hosted service, where T-hosted service is iHosted service. All right. So the notification dispatcher is what we're going to put here, and this is what it's basically going to start, and it's going to start looping it. So let's go ahead, implement the abstract class, and here we have a function, right? Execute async. It's going to start, and it's not going to stop running. All right. So this is that consumer task. So the notification dispatcher is a consumer, and it's going to try to read from the notifications channel. All right. So here we want our while loop, and if not complete, read from channel and send notification. All right. Real simple. Now we basically just have to put a pipe from the notification service, and again, this notification service can be something different, like create order, register the website, etc. Okay, sending emails, getting stuff from the database, writing to the database. These are all basically time-consuming tasks because there is that communication. So what we want to do is we essentially want to grab these services and just stick them in here. Okay. So for the HTTP client, right? So I'm just copy paste. I will then grab this functionality here, and I'm just gonna do the send notification, because that's essentially what needs to happen to send the notification. Okay, and this will have to be asynchronous, and any sync we will need the entity framework namespace. Okay, so once everything compiles, let me drop down the solution explorer. And by the way, the get string, I'm just getting something from the Microsoft documentation. So rename the constructor. So we have our database, we have our HTTP client factory. One thing with the database, we might need to get it from a service provider, and this is something we will handle if the error arises again. And go ahead, and usually what you would do is you would catch this whole thing, right? Like this, and you would log it. Let's go ahead and bring in a real logger. So logger, notification dispatcher, logger. Okay, and let's create this logger field. All right. So we're not touching channels just yet. Just getting all set up. We log error. Notification failed. Exception E. Let's go ahead. System, right? So log error, what it allows you to do is log an exception and then the message. Okay, and then any parameters that you want to put in. But yeah, that's essentially where we want to break point if anything does go wrong, but we never want to essentially break this loop of the notification dispatcher. Okay, so the channel, let's go ahead and connect this channel, right? In the startup, what I want to do is add a channel, right? So services, add singleton, and it's going to be a singleton because I want this channel to exist and it's just one channel, right? Never dispose. And we don't need the type. What we want to do is we want to grab the channel, right? So it's a channel class in Systems.Threading.Channels namespace. There it is, right? And what the channels here, so let's go ahead and quickly explore it real quick. We have the channels class on its own, and it's a collection of static functions which will create your channel. So we have a channel of type T, and it's an abstract class, right? So you can inherit from it. It inherits from channel of T write, T read, right? So we are going to write a type, we're going to read a type, and the standard channel that we are getting here has type in, type out, right? So going into this channel, we have the reader, we have the writer, same situation, and the primary thing, the really little subtle differences are just in the functions options that these functions provide you, the completion tasks, just how it works. All the concepts of read, is it done, kind of are there, and same thing for the, if I can get there, for the channel writer, mark it complete or try to write to it, right? And I will quickly glance over these functions once we get sort of writing this, but playing around with them should give you a pretty good idea of what they are, right? I just want to get over the real world example of where to use channel. Okay, so what we want to do is, because we're going to be passing around a string, I'm just going to go ahead and create an unbounded channel, which means as much messages as you want can go in this queue. Bounded channel is if you will have a lack of memory, which is rarely the case these days. You want to put a limit on your queue, and then uh, you're not going to get a memory overflow exception or whatever. So create unbounded channel of type string. This is going to return us a channel of type T, right? So here you can see the type channel of string. And this is now a service. This is now a singleton service that we can inject, okay? And there are techniques that you can, obvious object-oriented techniques you can use. You can wrap it. You can basically create this channel and put implementations of the reader and writer and inject reader and writer separately to different services. But here what we're going to do is let's go ahead and just inject this channel into an action and then into the dispatcher and make the action communicate with the dispatcher. Okay, so let's go ahead and grab our home controller. Here at the bottom, what I'm going to do is I'm going to create a public bool send C for channel, and from services we're going to go ahead and grab a channel of type string because that's what we have injected. And let's go ahead and grab this channel. We're gonna need the namespace. Let's go ahead and return bool true right here. And what I'm gonna do is I'm gonna grab a task of bool because this is going to need this will need to be asynchronous, because for channels, just quickly going over, we're going to be using the writer because we're going to be writing to the channel. And we have the complete function. We mark it as complete. Nothing is going to be written to this channel ever again, basically. We then have try complete is going to throw an exception if it can't complete it, right? The exception that you supplied. Try write and then wait to write async kind of work hand in hand, because try write is synchronous and wait to write async kind of lets you know when you can write. Okay, so this is primarily more if you have a bounded channel. Okay, you wait to write async and then you try to write async. If you are unsuccessful, you wait to write async again. Okay, if you choose to write async, you essentially combine the try write and wait to write async. When you can write, you will write. Okay, so that's pretty much what we're gonna use. Let's go ahead and just say hello. Right, simple message. Let's go and wait on this. Okay, and then we're gonna return. So we have a service, and what the main thing to understand is that we're trying to achieve this result of offsetting work. And if you scroll back to the video or remember the numbers, it was somewhere around 30, 40 milliseconds that we get per result with this whole shebang. So this is what we're trying to be. We're trying to beat the 30-40, and we're going to try to go back to the 6 and 7 milliseconds that we were getting from the beginning. Okay, so unbound channel, let's go ahead and service it in our notification dispatcher. And a couple of things with these services is this database is actually going to break. So just because this is a singleton and the database is a scope, again, it's just about dependency injection and lifetimes. Okay, but we're gonna fix that error. Let's first take care of the channel, right? While we are on the flow of the channels. Right. Grab our channel. Gonna initialize the field. So, if not complete, how do you use this reader, right? This is a consumer, so we're gonna be using the reader. We're reading from the channel. Consumer is reading, producer is writing. Okay. So completion. It will return a task which we just have to basically. If it is a complete, dude, this task completed. If not, keep looping. Okay, then let's leave the comments. We want to grab the message. Let's grab the channel. We will go to the reader, right? And kind of the same scenario as with the functions on the writer. It's more or less the same thing. We either want to read or write, right? But it's just the options that they provide you, right? So read all async. Do you want to read all the messages or read async just one message? Do you want to do a synchronous try read and wait to read async, which both of these are kind of comprised into a read async? So you try to read. If you're unsuccessful, you wait to read async. And once you're ready to read, you try to read. All right. If not unsuccessful, you're back to waiting. Here, you're basically, once you're ready to read, you read. All right. So that's what we're going to use. Let's go ahead and read the message. Again, this is asynchronous. We'll need to wait on this. And now let's sort this database provider, right? Basically, it's going to crash because it's a scope and the notification dispatcher is a single, right? Repeating myself here. What we want in is an iService provider. So let's grab the provider and let's create a field here. And where we're using this database, we want to grab a using statement, and we want to create a scope from our provider, right? And once the scope ends, we want to dispose of the provider. So database equals, we want to get the service provider, get required scope, and we're gonna grab our database that we injected. And yeah, essentially we read our message. We're not consuming it really, but if we need to, we can. Let's go ahead and put a breakpoint here, so if we reach an exception, we can know. Let's go ahead and also put a breakpoint here, so we know at which point we sort of start reading or starting to wait to read. And usually this is going to get hit at the application start, and then the thread is going to go do something else, right? Because this background service is started as soon as the server starts. Okay, so recap before we go. We add a singleton channel, so this is just a channel that exists somewhere in memory. And then we get a bunch of services that we inject into our notification dispatcher, which is going to read from this channel and is gonna do its thing, right? Doesn't matter what it does, it's all about reading. We then are gonna trigger the write to the channel by calling a controller action where we can inject our channel. And just to note, we can inject this channel anywhere we want. The notification service, we can inject it in there if we want. We're just gonna opt in for the controller action. Okay, so let's go ahead and run this. Let's see what happens. So here we hit the first breakpoint. As soon as the application start, you can see we haven't actually gotten our home page yet. I don't think we've actually hit the home page, or there is no home page even. So never mind. Let's go ahead and just F5 here. This will return the thread, and the application can work as it wants to, right? So what we want to do now is we want to send a request to home send C. So we send it, okay, and here we're entering this scope. So I will remove this breakpoint now. Just so you know, as soon as we push stuff onto the queue, it kind of starts executing in the background, right? So we're gonna resume, and here basically we loop back and we start to wait to read from the channel again. The service has come back. It is long because I've waited on the breakpoint, but we will see this run full speed in just a second, right? And then we are basically waiting again. Once I resume, the thread has given up control here. So I'm going to remove the breakpoint here, and you see we haven't hit any exceptions, so everything is working as expected. What I'm gonna do now is in the home controller, there are no breakpoints here. What I want to do is I just want to spam some sends. All right, so I'm gonna send 40 milliseconds, send again, 10, 24, 9, 7. So you can see we are getting the offset of the workload, and we're back at sort of snappy execution, right? And again, I think we can go back to send B to sort of get a comparison. So send B 64, 59, 46, 47, 33, 62, 36, 33. So like some kind of sportscaster, but you can see that uh, with the dispatcher, with the channel, we can have a separate, we can have the main task, and we basically offload, we separate one task to here and one task to here. So now we have two tasks running, and the notification dispatcher is this background task. And the way we connect them is this channel, all right? And whenever something puts something in the channel, the dispatcher is gonna read it and process it, right? And the channel has its own lifetime. Sorry, the dispatcher, the consumer, has its own lifetime. It has its own services injected, and it manages its own state. And all you're doing is passing the messages around, right? So yeah, this is pretty much a real world use of channels in a single application. Another big, really big way that channels are used in the industry is a means of a separation of concerns. So you have distributed system, you have microservices. The way you communicate between microservices is through channel services. So you will have one service put a message on the channel service in the cloud, and then some other box. You will have a cluster, so you will have many boxes. One of them will read from a channel. If basically if too many items start accumulating on the channel, you spin up more boxes, and that's basically horizontal scaling. If you're not fast enough processing requests, you get more virtual machines essentially, and that's pretty much where channels can be used as well in distributed computing. It's quite an important concept to note. But yeah, this will be it for this episode. All the code is available in the link in the description. If you have any questions, leave a comment. If you enjoyed this video, leave a like, subscribe. Don't forget to join my Discord server. I also stream on Sundays and Wednesdays, so make sure you tune in for that. And hopefully, I'll see you in my other videos.